Very good morning to the second day of GAN course. The today's session will go on Introduction to FRP, Micromechanics, examples on regarding that, FRP reinforcing bars, commonly available bars and properties, ACI 440, R 2015. Then there will be a coffee break. After that it goes on with design philosophy and consideration, primary differences between American design methods and IS 456 methods, design material properties, examples, and quiz 2. Thank you. I request the professor to continue. Thank you, sir.
All right, good morning. Sorry, we are starting a little bit late, but Dr. Das tells me that it's okay. But tomorrow let us start at 9. Let us, just stick to the time. I know. I'm sorry. I know. That's okay. No, I don't. I'm not saying. Generally, like if we say 9 o'clock, we normally try to start at 9. But tomorrow we'll try to start at 9. Is that okay, please? That way we'll keep the schedule and we will finish what we are planning to cover. So, before we get started, I'd like you all to get engaged again. So, what do you remember from yesterday? A few things. Can you please tell me a few things that you remember from yesterday? Just highlights of yesterday, just anything that you remember. Yes, sir.
It's a lightweight material.
Very good.
It cannot be used in compression members.
Excellent. Anything else? The 2 points. Lightweight material cannot be used in compression. Excellent point. Anything else?
How to design composite for
Yeah.
modulus? How to design composite for modulus, high modulus?
Yes. I told you the secret for this business. I say you want to make more money, give me high modulus. You'll sell a lot of bars. Good point. Anything else? Anything else you remember?
High strength to weight ratio.
Absolutely. Very good. High strength to weight ratio. That's excellent. Anything else from there?
Linear stress and behavior.
Oh, very good. I'm so glad you mentioned that because we will use that. So, linear stress strain curve all the way up to failure. Okay? No ductility. That means in our steel reinforcing bars we have yielding and then we have lot of yielding and then lot of elongation, then strain hardening. We don't have that in FRP reinforcement. Excellent item you remember. That's very good. Anything else?
Aspect ratio has to be minimum 100.
Yes, for the composite to be effective, you need to have a very large aspect ratio, and ACI defines minimum of 100. Like that. Good. Anything else?
We cannot combine CFRP with steel.
Awesome. You are all remembering the perfect. That means you are paying attention. I am so glad. I am happy because you cannot combine carbon with steel because unless you have some kind of coating, otherwise it will start diagonal corrosion, which is very dangerous. Oh, very nice. Does anyone want to add anything else? One more.
Stiffness of the FRP bar is more when compared to normal reinforcement.
No, I'm sorry. I beg to differ. It's the other way around. Okay, so for steel, it's about 200 GP, right? That we know. That is something we all know. For glass, it's about 40 GP. So it's much less than steel. If we can get very high stiffness, like a lot of modulus, that will be very useful. Hopefully we can. Actually, they are combining carbon with glass. Carbon is very expensive. We remember that, right? From yesterday. So carbon and glass, they mix and they are making hybrid composites. So you can gain both in terms of strength and in terms of modulus from carbon, and you fill the other stuff with glass. That way you're not as high as carbon, but not as low as glass. Okay? Anything else? Yes, that's a very good point. So under sunlight exposure, the composite will lose some mechanical properties. So we always want to protect it. How do we protect it? Either we use an indoor environment, that's one, or if you are living in outdoor environment, you need to put some kind of coatings. Okay, very nice. All right, should we get started?
Yes.
Thank you. Thank you for your attention. So, quiz number 1. Let's see. So, we are saying identify if the following statements are true or false. Number A, FRP composite will replace structural steel and steel reinforcing bars in civil engineering industry due to non-corrosiveness and high strength. Yes or no? See, that's the trick question.
Yes, but not in all structural elements.
Oh, see, there you go. Now I am starting some discussion, right? This is interesting. Some of you are saying yes, some of you are saying no. That means it's a trick question. So I wanted to start with a trick question. So do you agree or disagree? Disagree. How many of you agrees though? See, I think I discouraged you. No, feel free to disagree or agree, it doesn't matter. Of course, you will say steel has to be completely replaced with FRP because you are a producer. I'm just kidding. Don't take me seriously. No, I'm just having some fun because early morning we are all, we have to pay attention, right? So we have to get engaged, right? So, yeah, my personal view is it's almost impossible to replace steel with FRP bars because it's very high priced material, right? So we may be able to use it in some selective, definitely. We will definitely use where it is needed, but in general we may not be able to use it or we cannot replace it 100%, okay? So that's a false. I would give it a false if you don't mind. Do you all agree with me? Very good. Yes, please. That's right, yes. If it is performance based, absolutely. But in civil engineering, like I mentioned here, civil engineering industry, we are more interested in cost effectiveness. Yeah?
You should also limit the percentage of rebar, FRP bar. You should limit. Here, limit is not defined. 100%, 50%, how much percent?
Right. Yes, that's right. Okay. It's not going to replace everything, but some replacement will work. Yeah, agreed. Okay. Anything else? Okay. Number 2, CFRP internal reinforcing bars can be combined. We already talked about it. It's not possible. Okay. Number C, FRP internal reinforcement is ineffective in compression. You already perfect. Very good.
But if compression member having bending dominancy over axial load,
Yes.
in that case we can use this FRP bar.
You can place an FRP bar, but you cannot use the force from FRP bar. Does it make sense?
Yes,
Okay.
column will act as a beam.
Yes, beam columns. Yes, that's right. In case of beam columns, yes. So, Snehal, can you tell? So, let's say in continuous beams, for example, the very first one, the bottom, there. Oh, okay. Oh, okay. That's good. Okay. So, yeah, this is better. Can you all see me? Can you all see it? Yeah, that's fine. So let's say you have a frame. Generally in frame members we don't want to use FRP. We'll talk about it later. But if you are, let's say you have a bar like this, right? So definitely this bar here is going into tension. We all know that. Around here it's in tension. So those two areas we can use the tensile capacity of FRP bars. But what if you have a bar here? It is going to tension or compression? Tension, definitely. Now at this point, if I cut a section, you will see let's say that's my cross section. It has flanges, of course, and you have these bars, and you have these bars as well. So what I mean by discounting the compression bars or bars in compression area is you cannot use these bars for movement capacity. That's what it means. So you cannot use it for
Yes,
movement
but
capacity.
this is the minimum reinforcement in the bottom part, and maximum we are providing the tension zone.
Right.
So it is very strong in tension. I am not talking this part. I am talking in columns.
Columns, okay.
If you observe the PU and retraction curve, then we will observe the moment, bending moment dominancy zone.
Absolutely. When the bars are going, if it is below the neutral axis and if they are going in tension, you must use them. You can use them, or you should use them. But if they are in compression zone, you will not use them. You know what I mean? Whereas steel will be very, contribution of steel will be much more in compression area than FRP bars. So ACI code tells us don't use the contribution from FRP bars if it falls in compression area of a column.
Yeah, I
Section.
agree with this point. If we cannot use in compression member,
Right,
if the in compression member,
right.
bending moment is dominant over axial forces,
Uh-huh.
and it is near the bending zone,
Right.
and column will act as a pure flexural member.
Not pure, but mostly, yes.
In such conditions,
Yeah.
when axial load is negligible.
Right, but you still have, you still have neutral axis, and above neutral axis you will have compression, right? So if your FRP bar falls in that compression area, you cannot count those. Does it make sense?
Any percentage we cannot use.
Zero, nothing, absolutely zip, zero. You cannot use them. Because,
Steel has same property of like tensile,
yeah,
compression.
right.
Okay. But we are using for tensile,
Yeah,
not like the same one, not the same one.
make sense? Are you convinced?
Yeah.
Very good. Yeah, good question. Absolutely, I agree with that part. So now CFRP reinforcement is ineffective. That's good. It's preferable to fabricate shear reinforcement with thermoset matrix. I won't even read the rest of it. Yes or no? False, because once you have a thermoset and it's formed, you cannot change the shape. Very good. So glass is stronger in its fiber form because its bulk form stronger in the fiber form than its bulk form because the reorientation of links along the longitudinal axis of the fiber. True or false? I'm sorry? True. See, there you go. There are some you are saying true, some are saying false. So is it false or true? True, false. Which one should I take? Okay, if you go back to the slides, you will see the cross links are only for aramid and carbon. So the links are parallel to the fiber only for or in carbon fiber. For glass, it's because of the defects, air pockets. So if you are removing all the air pockets, that means you are able to gain strength. Okay, so just simple things that, but just try to go back to your PowerPoint and slides, and that will just refresh your memory. Okay. Yes. Yes, it is false because the gain in strength is because of no defects, no air bubbles, no air pockets because of that. Okay, very good. So give two examples of FRP application in transportation structure. Just two, one or two. Bridge decks, very good application. Yes, I agree with you. I like bridge decks. I work a lot on bridge decks. So precast elements. Yeah.
Sir, can we use it in concrete rigid pavements?
Absolutely.
Transportation
Oh yeah.
structure?
Yeah, absolutely. I just left with one application. That's the way. But yes, pavements, yes. But pavements it's more expensive, I think. Dowel bars, yes. But mesh, it's kind of expensive, I think, because it's cheaper to use fiber reinforced concrete in pavements than FRP bars. Okay, so precast elements, yes, sleepers, very good answer. Anything else? Beams? Pre-stressed, yes, pre-stress is, yes, but it's not common yet. Poles, yes, I agree, you can use that. Uh, walls is where they are using it extensively. Mhm. Okay, so let's not go too much into detail because we have to get started with our own material today. For today, buildings, of course, we know columns. Oh, I mean not columns, but slabs and beams. Sports and recreation, which I showed you a few slides. Boats, uh, everything. Yeah, that's good. Auto industry, yes, we already talked about the hood. Very good. Uh, just mention a couple of, we already talked about it, so I will skip this because you brought it up, which is very good. That's all. That's your quiz. Everyone gets 100%. That's how it works in America also. Like, you attempt, you get 100%. Done. The whole point is, it's not, we're not trying to grade you. It is just we are trying to encourage thinking. You think more, you think with others, and then you agree, disagree. That's what is important. So I think yesterday we stopped here on slide number 30, that's what I think. So what I will do is I will quickly browse through these slides. They are all self-explanatory, so I will just let you go over that in detail, okay? There is some repetition, so we can always skip that. So we have different types of glass fibers. We have types. Okay, this maybe it's useful to understand this. So if you say glass fiber doesn't mean everything is glass fiber. It's not just one type of glass fiber. There's so many different kinds of glass fibers. That you have e-glass, which is electrical grade, and then there are some advantages and disadvantages. I'll give you a little bit of information on pricing. It's about $1.60 per kilogram, or $1.60 is about 100. Maybe about 150 rupees or something like that. So that's a little bit, it's considered to be low cost, okay? And because the material is very light, you will get a lot of volume for 1 kilogram. And before I go into the slides, I want you to take a look whenever you have a chance during the break or after our sessions. Take a look at these bars. I showed you pictures of these, but I did not get any of these. Our good friend brought these bars for us. Excellent samples. I have, I'm a little bit bold, so I'm holding them bare hand, but don't do it. Don't touch them. They will give you a little bit of itching. Don't put your finger, after touching it, don't put your finger next to your eye. That will definitely give you itching. This is stainless steel. You want to see a stainless steel bar? This is what it looks like, okay? This is a little bit newer version of these bars. Like we are trying to reduce the cost of the bar. Stainless steel is very, very expensive, unfortunately. This is the regular carbon steel bar. This is the epoxy coated bar. Some of you have used it. You know that you know what it is. And if you have not used it, take a look. And this one is dual coated bar. This is what I was talking about. It has zinc coat inside, and on top of it, it has also epoxy coating. Okay, so dual coating. But like our friends have actually highlighted, there's a lot of problems with epoxy coated bars. Primarily bond related. And these are glass bars with sanded surface. That's fine, but I don't want. Sorry. I know I trust you, but you know, I have to take care of myself. No, these are standard bars. Okay, these are uh, glass or basalt bar, glass bars. Glass bars. Okay. Well, E-glass. E-glass. Okay, these E-glass bars, and wine lister or epoxy. Okay, epoxy bars. So epoxy is cheaper than wine lister for sure, but performance-wise, wine lister is slightly better. It's more expensive for sure. And you have carbon strips. You can glue these to the underside of the bar, underside of the beams and stuff like that. And laminate with end anchors. Dr. Das, do you know what this is? These are, I'm not sure, they are anchors, with anchors, that's what they're saying. It says grooved laminate with end anchors, that's what it says. I don't know what it exactly does. But take a look at these ones. This is the mesh or mat. So for wrap applications, you use this. Okay, so take a look. And I have a lot of stuff here, basalt fabric, basalt fiber. Definitely don't remove this from the Ziploc bag. There are what's known as minibar products. You can take a look. And then you have your protruded sections. And this is the honeycomb section. Okay, so you have two plates and the honeycomb in between. You fill the foam, which is structural foam. It's not any ordinary foam. So the foam will carry the shear load and the laminates, the two plates on the two sides of the honeycomb will carry the flexure loads. Okay, those are the standard ones. This is from a recent application for aerospace industry. We are just starting some research on this, so should be interesting. And this is basalt bar. Definitely don't touch it anywhere other than the tape area. And this is your regular strand. So what's the normal grade for your strands here? 1700. 1700 is about 250, right? 250. 1700 is about 250 KSI. So yeah, KSI, that's what about that. So this is slightly stronger than that, 270, which is no big deal. And here we have carbon fiber cable strand, same.